Good afternoon, everyone. So my name is Anthony Lee. I'm currently part of the field engineering team here at Verta. Just a quick background about myself. I joined Verta roughly around the beginning of this year. Again, focused really on the customers, the use cases, et cetera. Prior to that, I was at a company called Domino Data Lab. I'm sure you guys are maybe familiar with them. They are attending ODSC as well. But yeah, the main purpose of today's session is I'm just gonna go straight into the product. I want to give everyone a high-level overview of the Verta platform. I know this space is, there are a lot of different vendors. There's a lot of overlap. So I definitely want to make it pretty crystal clear what we address, what we don't address, which is the whole model ops. We like to say model ops rather than ML ops because that buzzword you hear a lot. And yeah, feel free to, I see that GoToWebinar has a chat, so feel free to insert any questions in the chat, and I will do my best to keep an eye on it and address it along the way. All right. So let's go ahead and kick this off. So what you're looking at here is the homepage of the Verta platform. The scenario I like to take you today through is basically a day in the life of a typical data scientist, right? So we like to show that on this left nav over here. So data scientist usually does, some development, there's some training, some testing, some iterating, etc. From there, I want to move into our model registry. So that's kind of that central repository of all your models after you've finished the training. And then the last module of Verta I want to cover today is really the ability to operationalize some of the models that you have in the model registry. So those are kind of the three key pillars that I will walk through in our demo today. So the first module of Verta is this development phase. And underneath the scenes, what this really is this is Model DB. So Model DB is an experiment manager tracking system that our CEO and co-founder actually developed in her PhD thesis. So this is one component of Verta. This is actually open source. We have an open source free version of it out. So you're more than welcome to go ahead and download and play with that as well. But let me just jump into this Model DB, the experiment tracking within Verta. You can see here I have a bunch of different projects. You could think of a project as basically a folder, right? So it's just a folder on your machine. Here I'm jumping into the census income classification. And here you can see some basic metadata around this particular project. The next level down we get is, we like to call it into experiments. So you can almost think of this synonymous as like a subfolder, right? So you have a top level folder and then you have subfolders. So if you think about an experiment, a classification, there are many type of different libraries and packages you can run, whether it be like scikit-learn here, logistic regression, or you're using like PyTorch, TensorFlow, et cetera, et cetera. So it's just a quick way of organizing your work. And then lastly, the most granular way we do a lot of our tracking is what we like to call experiment runs. So you can see I have a big list here of different runs. You could think of a run as, it could be one run of a notebook cell. It could be one run of like a .py, .sh file. It could be one hyperparameter sweep, right? So it could just be any combination of that. But ultimately what Verta is going to do is, being this is the experiment tracking system, is we're going to track a lot of the information that is unique, that correlates to that particular run. So here I just jumped into one. You can see quickly up on the top some basic metadata information about this run. For this particular one, I'm capturing a lot of different information, and I want to start off by saying everything that I'm showing you here is completely flexible. It can be optional. You can choose to capture almost none of it. You can capture like anything you want, literally anything you want. And I'll show you in a little bit via notebook how these are actually captured. So I have some hyperparameters here, just capturing the accuracy. Attributes in Verta is what we like to say is basically like a catch-all type of section. So if you have just a key value pair, a string, a chart, just any additional type of data or context that is relevant to this run that you want to capture, you could go ahead and throw it in the attributes if it doesn't belong anywhere else. So that's what that's for. Down here are artifacts. You can think of artifacts as basically like a blob storage, right? So do you have an actual physical file, like a pickle file, a bin file, whatever you want, you can go ahead and dump that here as well. We have integrations with external Git. I'm sure everyone's using some type of repo, so you can link that there. And then we also track the underlying data set as well. So what we actually track within Verta is the metadata behind the data set that run is particularly using. So in this example, you can see this is an income S3, so it's an S3 bucket. I'm just choosing 2 different versions that were committed earlier. And you can see by capturing the metadata, frankly, it's just like a list. It's just an LS, a list of that particular bucket. And again, we're capturing the metadata behind it. If you think of this as like a database, we won't be actually capturing the data, maybe just a query, right? Because that's kind of like the metadata behind a database connection. So that's what we're capturing here underneath data sets. And then also for the purposes of reproducibility, the purposes of auditing, governance, etc., we're also capturing the environment as well. So we really want to give you a 360 view of everything that correlates with this particular run. And then if I jump back here, as you guys know, you guys are probably iterating, doing hundreds and hundreds of runs. From this interface, you can also quickly slice and dice it. So I have filters over here on the left side. I can do a quick sort. And if I jump over here to charts, this gives me a quick visualization of actually what's going on underneath the scenes. So again, runs, you typically have hundreds, if not thousands of it. And this is just a quick way to see, oh, hey, what parameters are producing the best outcome, or what is my trend over time, et cetera, et cetera. So I can go ahead and customize this dashboard. I can go ahead and add additional charts on a need basis. So there's a lot of flexibility in terms of what I can do here. So this is the experiment manager in the Verta web app. Let me actually just jump into a notebook and show you how I got all this information into Verta. So this is a pretty standard vanilla Jupyter notebook. The main thing I want to point out here to start off with is that Verta is just pretty much a Python client, library that you're installing, right? So pip install Verta, pretty self-explanatory. This makes us really agnostic in terms of where you run a lot of your workloads. So Verta doesn't really focus on the training. We don't really care where you run it, whether it's on-prem, in the cloud, what vendor, et cetera, et cetera. It doesn't really matter to us as long as you guys can install our package and have connectivity into the Verta platform. That's really all you need. So here, I'll just quickly brush through this notebook, some basic Verta setup, making sure I have the package, some environment variable setting, and then for the sake of this notebook, just additional imports. Here I'm actually instantiating the client. Preparing the data, so I'm actually going out to a S3 bucket, wgetting it, downloading it locally, and here's where I can commit a version of that particular data set if I want to do that. Scrolling down here, so some basic feature engineering, just doing some classification, preparing my hyperparameters for a grid search. And then lastly, over here on the train models, this is the big cell that I would like to you to take your attention to. So this function run experiments is ultimately where all the work is being done. So you can see here, we're actually creating a run. So run, you're using the client, you're setting a run. And this is a run again would be associated with one of these rows here. And then you can see we're doing run.log attribute, run.log hyperparams, run.log metric, et cetera, et cetera. So this is where, again, all the magic is actually happening to log it into Verta, and this is what the sample output looks like. So the other thing I want to mention here is this is an example of manually logging it. We do have auto log features to all the deep learning frameworks out there, et cetera, because they collect their own unique information such as like network topology, right? So we do have auto logging capabilities as well. And then the last thing I want to mention here is that all this information is really great, and I showed you some ways to analyze it within our web app, but a lot of people have their own visualizations tools, or they want to go ahead and export it. And this is just a really simple, basic example of me applying a basic filter and storing all the information that you see here in this table as a pandas data frame, right? So now that's stored as a data frame, you can imagine the possibilities are really endless if you want to do additional slicing, dicing, et cetera, however way you want to. Okay. So that, in a high level, is the first module, again, of the Verta platform, and that is our experiment manager, experiment tracking. So again, just a quick summary, being the single point of view, point of contact for all your all your training, all your iterating, and a good place to actually track what your runs are actually doing so that you could quickly organize and analyze it. From there, the next logical step, the next module of Verta is what we like to call the model registry, right? So what we like to think of the model registry as is think of it as like this handoff area between what we typically see in the market as like your data scientist and your IT, right? So I'm saying data scientists because those users are the ones actually doing the heavy lifting, the difficult work. But then we typically see that there's a transition to, hey, I actually need to get this deployed or implemented somehow, somewhere. And that's where we typically see another team is contacted to do some of this work. So I'll call that like kind of the IT team. So this is the handoff area, right? So it's kind of the in-between layer. Because if you're iterating through like the experiment manager tracking, you could have hundreds. This is a good way to go from 100 to 5, so it's a little bit more organized. So here's our model registry. I'll just jump into one that I have over here. You can see in the web app, a similar interface. I could jump over here to versions. And as you guys know, models are constantly changing. So we allow you to have multiple versions of the same model registered within this one interface. If I just jump into one, you can see some more information about it. So in a similar view, you get a lot of the basic metadata that correlates to this particular version in our registered model. You can see that this one was actually promoted from an experiment run. So if I do a quick drill, you can actually see, and this is the same interface that I showed you earlier, the run interface. And this was actually, we have the seamless integration to our model registry. So this was promoted up to be a registered model because maybe it had the highest accuracy, right? That's just a quick example. So we have that capability as well. And then from here, a couple other things. We automatically package every registered model as a Docker image. So Verta in the backend, we're a Kubernetes native application, and everything that we do is containerized, right? We leverage microservices. That's a big trend these days. So we do that automatically for our end users. And that's because, and I'll talk about this in a little bit, for deployment purposes, right? So you do have the capabilities of deploying in Verta, within Verta, or externally as well. You do see this error here. This is intentional. So after we go ahead and package it up as a Docker image, what we do out of the box automatically is we scan it for vulnerabilities, right? So a lot of our enterprise customers, they're like, okay, great, you're creating a bunch of models that the user could potentially deploy, but how secure are they? So we plug into a lot of different external vulnerability scannings. And in this particular example, I'm using AWS, I think ECR. And if it is below a certain threshold, it's going to flag it, right? It failed because there's a CVE that came out last month that this image is vulnerable, right? So we have that checkpoint there in case, this something is bad and you definitely want to provide that sanity check. If I scroll down, again, this is a lot of things that you saw earlier in the experiment run. You can have attributes, again, a catch-all for any additional information, the artifacts, their environment that the image is actually using, and the dependencies, etc. So that's all there. Another thing that's unique for each registered model is the concept of approvals. So a lot of times if you're thinking, oh, I have different teams that need to go ahead and look at this particular registered model before we actually go ahead and deploy it, I have the ability to kind of move through stages, right? So going from, in this example, staging to production, development, archive, etc. And then you'll need other users to go ahead and approve it. And then after it's approved, for example, you could say only if it's in production it could actually be deployed. So we have kind of that sanity check as well. And then the last thing here I want to mention on our registered model is this, what we like to call this Verta standard model spec. So here at Verta, we have a model specification. Let me just jump to it real quickly. And pretty much anything that you can imagine, we can go ahead and package it up for you as long as you fit this base model class and you extend this model spec. So we have a basic initializer, we have a predict function that's actually being invoked when you call the model, the endpoint, etc. But you can think of it, this is very, very basic, but the possibilities are really endless, right? A common use case, one that I just worked on, for example, this week is like, hey, a lot of times our models, it requires a certain amount of features, let's just say A, B, and C, but then the user only inputs A. So how are we going to go ahead and populate or hydrate the input of B and C in order for this model to be successful, for this call to be successful? So you can actually code in here, but this is all Python, to go out to some type of external, it could be a warehouse, it could be a feature storage, etc., and do a quick lookup, and then you can go ahead and pass that along here. So pretty much allowing for a very open platform, and any type of model that you want to go ahead and deploy that you don't really want to promote from an experiment run, we have that capability of doing that too. So integrations with like H2O, or you want to deploy one of their models, you have that capability here, as long as you are able to extend our Verta model-based model spec. So that's the last thing I want to mention here. All right, and then, so this is our second module of Verta, our model registry, and a quick summary. Again, this is kind of that in-between staging handoff area from what we commonly see the data scientists use after they've finished, iterating and figuring out, hey, what version of this particular runner model is best, and before they actually go ahead and productionize this and actually start making calls to it for further testing. So the next and last module I would like to cover is the deployments, right? So deployments are basically, hey, now I have a bunch of register model, that's great. I actually want to go ahead and deploy this so I can actually start making calls to it. So Verta really, in this concept of deployment, we really have two approaches. The first approach I could show here in the web app, it's pretty straightforward, is that Verta as a platform actually goes ahead and spins up the instances, spins up the containers, pods, etc., in the Kubernetes infrastructure, and actually stands up this model for data scientists and other users to actually call. So that's what we call the in-platform kind of deployment method. The second method that I can't really show here much is really third-party integration. So two common examples that we support that we have customers using today are, one, Spark. So remember how I package everything up as a Docker image, a Docker container. We also have the ability to package it up as a Spark UDF. So then you could go ahead and run Spark data frames, etc., run in your Databricks cluster, etc., and then really leverage their powerhouse there. And then another example of third-party integration deployments are with Kafka. So we have integration with that as well, where we can deploy to Kafka topics and then have them handle a lot of that workload too. So we have documentation on all this, but for the sake of this demo, I'll just focus on what we do within this web app, and then I'll jump into a notebook to finish this and talk about how we register models, how we deploy it, all automated via code, etc. So here, here's an endpoint. So some metadata. Again, you can see, who's using this. You can see the particular model version and the registered model version that this came from. Here's a sample model playground if you want to go ahead and send it some sample payloads and see the output. And once again, the package formats that I talked about earlier in the model registry is here as well. As you guys know, each model gets a unique URL, so we go ahead and deploy everything, and then we secure it via access tokens too. And then you can do additional auditing if you need be based on these access tokens to see, who uses what, when, how, etc. So that is all tracked in the back end. Over here, we have some basic IT monitoring. So things like latency, throughput, you can go ahead and track that. We have logging. So when you're actually building the image, we provide logs over here when you're actually building it. And then we also have runtime logs as well. So you can see, hey, who's actually calling it, etc. So that can be tracked here. And this is probably taking a little because it's actually being used. And then lastly, the last part I want to cover before I jump into the notebook is just update patterns, right? So as you know, models are constantly changing, they're being updated. I want to go ahead and update this one particularly to maybe a new version. So we can select the source, you can select the registered model, the particular version, etc. So that's over here as well. We have auto scaling built in. So you can scale on different types of metrics, such as the number of requests, memory utilization, CPU utilization as well. You can set environment variables if you want to use that, and enable particular resources if you want to specify that too. And then the last thing here are the type of updates we do. So direct rollout is pretty It's what it sounds like. It's just direct. It's just a rip and replace. I'm going to spin these pods down, spin up new ones. While Canary is more of a gradual change, right? So I don't want to completely stop traffic to the old one. I want to gradually shift it so it's not instantaneous. So we have that capability too. All right, so that is what we have in the web app. Let me just finalize this demo with jumping into the notebook and finishing off on what we did a little bit earlier, just talking about how do we register models, how do we deploy it, etc. So from here, we've done a bunch of experiments. We searched through the results. Now, actually, I want to do a quick sort, right? So I want to find the experiment run that has the highest accuracy, and I want to go ahead and train it on the full training set. And then from there, this is how I actually go ahead and register that particular model into the Verta platform. So here I'm recalling the client, I'm getting or creating a new registered model, and then I'm creating a new version from a run. So again, this is just taking the RUM that I found up here, and I'm just creating a new version. This is V0, etc. And this is basically the sample output you have. And then from there, I can go ahead and deploy it pretty simply. So I have a registered model. Now I'm just getting it. So I created it on the step above. Now I'm just getting it. And then I'm actually creating a new model itself, right? So the deployment, so I'm getting the particular version. I can download it as a Docker image if I want. And this allows me to go ahead and publish it maybe to SageMaker or something as well. So I have this tarball that is all packaged up with all the dependencies, all the requirements, etc. And I can go ahead and send this out to a third-party system. And then here I'm creating the endpoint. So getter create endpoint, and then I'm just updating that endpoint with the latest model version that I have specified up here. And that's really it. So it's pretty easy, pretty lightweight on how you can interact with it. We're completely an open platform in terms of not only are we agnostic how you interact with it, but we also have open APIs. So a lot of our customers actually have a lot of these processes all like built into an existing CI/CD framework, et cetera, to really automate a lot of this for production deployment. Cool. So with that, that's what I wanted to talk about today. That's a brief overview of Verta and our enterprise platform. I don't know if anyone has any questions. I can open that up in the chat, or I guess you can speak as well. No questions? Cool. Well, if no questions, thank you all for attending. Again, if you guys would like to learn more, you can just go to verta.ai. And yeah, and then again, we have pretty good documentation. Our website provides some good context on like what we actually do, where we fit in the AI ML lifecycle. So yeah, feel free to reach out if you have any more questions, or you want to have a better understanding, or you want to evaluate the tool.